Good day, everybody. I hope you are doing great this morning. Today, we are going to talk about hypothesis test for small sample. So here I go. Says a study finds that the students on average spend 18 hours per week on leisure activities. To test this claim, a random sample of students was selected. The survey with this sample revealed that the following time spent on leisure activities by 10 students: 14, 16, 19, 22, 23, 25, 26, 38, 33, and 41. Assume that this time spent by the students in leisure activities is normally distributed. Does the sample data provide enough evidence to support the claim? So let's write the claim. The claim is the null hypothesis. Mu equal to 18 hours. That's your claim. And that's the null hypothesis. Status quo. Since we have not been told whether the test hypothesis or the alternate hypothesis, sometimes written as HA, we do not know whether it is greater than 18, whether the mean is greater than 18 or less than 18. So a safe bet is to assume that mu is not equal to 18. This is your alternate hypothesis. This says mean is not equal to 18. So with the alternate hypothesis, containing not equal to, containing the sign not equal to, not equal to. This is a two-tell test. Okay. What is a two-tell test? You ask me, I'll explain in a minute. However, notice that n is equal to 10, which is less than 30. N is your sample size. However, the sample came from a normal population. Came from a normal population. Okay. This means the sample times are distributed normally or bell-shaped distribution or bell-shaped distribution. Bell-shaped distribution. Okay. So if I can create some more space. Also, the samples, the population standard deviation is not known. population standard deviation, which is sigma. This is sigma, small s, is not known. Okay, so in this case, we'll use a t distribution. Okay, for the sample means, or assume a t distribution for the sampling distribution. We would have used a z distribution if we had known sigmas, but since sigma is not known, we'll assume a t distribution for the sampling distribution. So the question is, how does a t distribution look? The t distribution looks like the z distribution, only it is thicker at the tail. So it's a bell-shaped curve. Let me draw it a little bit better. It's thicker at the tails. Something like this. At the center, so this is T on this axis. At the center, where the peak is the highest, this is T is equal to 0 on the horizontal axis. Okay, and T distribution depends on degrees of freedom. So degrees of freedom df is n minus 1. In my case, degrees of freedom, since I have a sample size of 10, 10 minus 1 is 9. Now our level of significance alpha is equal to 0.05. Okay. Remember, our null hypothesis 80 is mu equal to 18, and alternate because we do not know whether it is actually greater than or less than 18. We will test mu not equal to 18. This is called a two-tail test. What does it mean? It means, if I take the level of significance, take alpha, level of significance, and divide into two equal parts, and divide alpha by 2. So it will be 0.05 by 2 is 0.025. So there will be two tail areas, each with area alpha by 2. This is alpha by 2. This is also alpha by 2, which in our case is 0.025. Okay, so we have to find this critical value of t where the vertical line. Okay, first of all, let me tell you the unshaded region inside the center is where we do not reject 80. and the shaded region is where we reject 80. So the rejection region of the null hypothesis can fall in the left tail or in the right tail. So this particular value of alpha by 2, notice at the center where the peak is the highest, t is 0. So on the left hand 0, on the left of 0 on the horizontal axis, it is negative. So this is minus t alpha by 2, this particular value. Why? Because the area to the left of it is alpha by 2. And this particular t, critical value t on the right, is positive t alpha by 2. Why positive? Because on right of 0, everything is positive. So plus minus t alpha by 2 are called the critical values of t. Values of t for degrees of freedom. In our case is 9. Okay. So we need to find from the using the calculator what are the critical values of t. Just give me a minute, I'll get the calculator. I hope you did not quit. Please stick with me till the end, and I will show you how I did it. So please subscribe to my channel, Math Science Topia, where I've solved all kinds of algebra and stats problem just for you. So we know the area of each tail is 0.025, and the degrees of freedom is n minus 1, in this case 9. We need to find minus t alpha by 2 and positive t alpha by 2. T alpha by 2 are critical values. So how do I do it? Let me write that for you. So use TI-84 to find first minus t alpha by 2 for n minus 1 equal to 9. Okay, how do I do it? Okay, so I will press the second button and then the verse button. Second button on the top left corner of the calculator, TI-84, and verse button is in the third row, second verse. Now scroll down to, with the down arrow key, scroll down to number 4, which is in T, which is number 4 in T. So when you're a number 4, so second verse, scroll down to number 4, okay? And let me create some space. They will ask for, so you'll see a screen open up in T. They will ask for, so let me get that. Area is area in each tail, which is 0.025. This is area in each tail. I already explained that I divided the level of significance of 0.05 into 2 equal parts, one in the left tail, one in the right tail. This we'd only do when we have two-tail test, when E not equal to is the sign for the alternate hypothesis. So area type 0.025. Then it asks for degrees of freedom. We already know it is 9, so type 9. Then you go down to pest. Go down to pest means bring the cursor on pest and hit enter twice. Enter twice. Twice. So while the cursor is on pest, and hit enter twice. and you will get the critical value minus T alpha by 2 as minus 2.262. 262. So here's that. 2.262 by symmetry. T alpha by 2, which is on the right side, same value without the negative sign. So let me again draw the picture, what's going on now. So first I have to create some space. Okay. This is the T distribution for 9D for df equal to 9 degrees of freedom is 9. So at the center, okay, and you have two tails. This is T is equal to 0, okay. So this area is alpha by 2 is 0.025. This area is also 0.025. Okay. So this is minus 2.262, this critical value, and this critical value is 2.262, positive. So where we do not shed is where we do not reject H0. Okay. We will calculate a test statistic which is a T, and determine whether it falls in the rejection region, which is the shaded region, in the rejection region, which is two tails. Okay, the rejection region where we reject H0. What is alpha? This is alpha by 2. This is the area of the 0.02. Okay, so reject H0. In the shaded region also reject H0 on this side. Okay, whether it falls in the rejection region or in the center, which is do not reject H0. Okay, so we have to calculate the test statistic. How do I do the test statistic? Let's move it up. Okay, so the test statistic, oops, let me use a different color. Test statistic T is given by x bar minus mu 0 over S divided by square root of n. Let me explain each of these terms. X bar, as you know, is sample mean. Mu 0, value in the null hypothesis. In our case, it is 18. Sample standard deviation, we will find out. Sample standard deviation. Then n is sample size, which in our case is 8. Sorry, is 10. So sample size is 10. Okay. So first we will enter the data in L1 of the calculator. Please do not quit. I will give you some important tip at the end of this program. Tip or hint at the end of this program, which will help you to solve this program, type of problem quicker. Okay. Instead of going through all this long calculation, I'll give you a tip which cuts down the time of calculation. Okay, so if I move up, I want to enter the data of the sample time in L1 of the calculator. Here are the data. Okay, this is the data 14, 16. So first we'll clear the memories of the calculator. Second button, then plus button on top of enter, then number 4. Clear all this done. Then we are going to enter the sample data in L1. Stat 1, 14, 16, 19, 22, 23, 25, 26, 38, 33, and 41. 10 data points in L1. I need to calculate the sample mean and the sample standard deviation so that I can plug it in the formula. This is the formula to calculate the test statistic. Okay, so let's write it down. So we will press the stat button, then highlight calc on the top row, then number 1 where stats, list is L1. I scroll down to calculate, frequency list second line should be empty. Scroll down arrow key, shift the cursor to calculate and hit enter. This will give you the value of X bar, which is 25.7. Also SX, which is the sample standard deviation, is 9.044, you might say. Okay, so let's move this a little bit up and calculate the test statistic. So test statistic, T, this is your test statistic. Now, when we say test statistic, it means a characteristic of the sample that we have covered. Remember, the formula is X bar minus mu 0 S divided by square root of N. So in our calculator, we will first type a left parenthesis, then the X bar value, which is 25.7. Our hypothesized value in the null hypothesis is 18. Okay. Then we will divide. So second bracket, first left bracket, 25.7 minus 18, then right parenthesis. Left parenthesis and right parenthesis separates the numerator from the denominator. Then left parenthesis again, Sx is 9.044. That will be divided by. Now we have to invoke or bring in the square root, which we will do by pressing the second button and X square button. And this will bring in the square root. Inside it, type 10 and then put the right parenthesis. So let's calculate the test statistic. Okay. So again, left parenthesis, 25.7 minus 18, right parenthesis, divided by, again, left parenthesis, 9.044 divided by second button, and then X square gives me the square root 10. Inside the square root, under the square root, then right parenthesis and hit enter. The test statistic comes out as 2.692. Just to remind you, we have identified earlier the critical values of T. So this is T is equal to 0 in the center. And we have a critical value on the left, critical value on the right. If I move up, I will, okay, this is 2.262. So I calculated the critical value, this as 2.262. This is the critical value of T. This is this value. critical value. Similarly, on this side, the critical value is minus 2.262. Okay. And in the center, T is 0. Now my test statistic is 2.69. 2.69 will be greater than 2.26. Remember this area on the left tail and the right tail where we reject H0. Now 2.69 will be somewhere over here. This will be 2.69 somewhere over here. So we say since the test statistic 2.69 falls in the right rejection region, decision is reject H0. Okay, that's my decision. Okay, so I will highlight that a little bit. Reject H0. Okay, and what is my conclusion? My conclusion is, again, I write this clearly, reject H0 is my decision. Conclusion is if we reject H0 at alpha equal to 0.05, there is enough evidence to support HA. What is HA? HA states mu is not equal to 18. Okay. So that's the long way of doing it. And I will stop here today, but I want to give you a quick way of doing it. What is the quick way or faster way of doing it? Okay. So that was my hint or tip at the end of this. I hope you stuck with me, and we will give you a hint at the end, as I said, or a tip. So let me create some. Okay. So again, let me write this. Let me change the color to something nice. What should be a nice color to use here? Maybe a lighter blue. We will see. Quicker way. So that was my hint at the end. Quicker way to do this problem. Okay. We first write the null hypothesis is mu equal to 18. Alternate, since we do not know whether it's greater than or less than, we will write not equal to 18. It is not equal to 18. So it's a two-tailed test. Okay, because HA contains the not equal to sign, contains the not equal to sign. Okay, so how to do it quickly? So we have already entered the data in L1. We have already done that. Okay. We do not know sigma, population standard deviation. Thus, we will use a t-test. We will use t-test. not z-test. This is very important because we do not know the population standard deviation. Okay, so we have entered the data in L1. Now, how to do it quickly in the calculator. So, press the stat button. Oops. Stat. Press the stat button. Then highlight means move the cursor to test on the top row. That is what we call highlight. Stat, highlight, test. Okay. And then select number 2, which is t-test. We are not using a z-test because we do not know the population standard deviation. Okay. First line, it says input. INPT stands for input. That cursor should be flashing on data because we have entered the sample data in L1. Okay. Next line, it asks for mu0. Mu0 is the value. And I will make it clear by writing here, this is mu0, value in the null hypothesis. So put mu0, type 18. Okay. Type 18. Okay. And let's move this a little bit up. Next line is list, which is already L1. Leave it like that, L1. Okay. Frequency is 1 because we have entered each data point 1. Do not touch it. Leave it at 1. And then the fifth line is the alternate. Remember, we are testing for not equal to. So in the fifth line, which is, this is your HA, this line will tell the calculator what is the direction of the alternate. Remember, ours is not equal to mu0. So bring the cursor on the first option, which is not equal to mu0, and hit enter so that it's flashing on not equal to mu0, and then calculate. Then put the cursor, or with the down arrow key, put the cursor on calculate. And hit enter once. And you notice the test statistic, T, this is your test statistic. The same as before, is 2.692. What you are interested is the p-value, which is 0.0246. Okay. Compare, what is this p-value? Let me explain that first. So please hang around and please wait till the end. I'm explaining what is the p-value. P-value is the probability of obtaining a test statistic at least as extreme as 2.692. Okay. So that's the probability of getting a test statistic at least, means the lowest value is 2.69, it can be higher, at least as extreme as 2.692. Compare P with alpha. Remember, alpha is the level of significance. Okay. So here alpha given to us is 0.05. So P is less than alpha. Okay, if I move this a little bit up, when P is less than alpha, okay, because P is 0.0246. Decision, same as before. Reject 80. This is probably a faster way to do the calculation. Decision, same as before. Reject 80, and in this case, P is less than alpha. Okay, if I move it a little bit up, then the conclusion is same as before. At alpha equal to 0.05, there is enough evidence to support HA. To support HA. Because we have rejected the null hypothesis. HA is mu. It was mu not equal to 18. So we are supporting HA because we have rejected 80. I will stop here today. If you like this video, please give me a thumbs up. I really would appreciate it if you please give me a thumbs up. Many of you, please give me thumbs up. Each of you give me a thumbs up because that motivates me to to work on more problems to help you to understand, to help you understand stats. So please give me a thumbs up. Please write me a note. If you like this video, share with your friends. You and your friends, please subscribe to my channel, Math Science Topia, by hitting the red subscribe button and let YouTube know that you'd like to be notified every time I upload a new video. So please subscribe to my channel by hitting the red subscribe button at the bottom right corner. The name of my channel is Math Science Topia, where I've solved all kinds of stats problems just for you. Please do not forget to come back tomorrow when I'll discuss another problem, another new problem, another new solution. Again, thanks a lot for watching and look forward to see you tomorrow. Take care. Have a nice day. See you next time.